Sairam students. In our previous lecture, we had started with chapter number 3 of Science A. The chapter was Chemical Reaction and Equation, right? In that chapter, we had started with the chapter with various topics like chemical change, physical change. We have seen various examples of it, the video related to it. Then we had studied about the chemical reaction, the definition of chemical reaction. Then we studied about the chemical equation. What is a chemical equation? Okay. What is word equation? What is the difference between the two? Isn't it? And then we have seen video related to it. We have also studied the various steps by which we can write a chemical equation. What are the rules for writing a chemical equation? Isn't it? The last topic that we studied was law of conservation of mass. If you remember, we have understood it with the help of a diagram that mass of an object cannot be created nor be destroyed. Okay, now based on that, today we are going to continue with our chapter. Here, students, as I have already told you, you will always keep a notebook and a pen in your hand while my lecture. What you can observe here is I have written a reaction. You all can see the reaction. We have silver nitrate, which is in aqueous state, plus sodium chloride. Again, it is aqueous. Okay, when the reaction takes place, silver chloride and sodium nitrate is formed. Isn't it? You can see the reaction. Now, what you are going to do? You are going to do one activity. You can see the table below. Okay, we are going to write the number of atoms of reactants and number of atoms of the products individually of all the elements. Okay, for example, Ag, silver, you can see in the reactant part how many atoms of silver is there? 1. So you are going to write 1. And how many atoms of silver in the product? 1. You will write 1. So I'll give you just a minute to just fill it. So you must have got this answer. I have written the answer as well. We can see that silver, there are 1 atoms on both the sides. If you see nitrogen, it is also 1 atom on both the sides. Then oxygen, you can see there are 3 atoms of oxygen in the reactant and 3 atoms of oxygen in the product. Then we can see sodium atom is 1 on both the sides and chlorine atom is also 1 on both the sides. So by this we can say the law of conservation of mass. Mass cannot be created nor be destroyed. It should be same for all, isn't it? So you can see here it is a balanced equation. The number of atoms in the reactant and the number of atoms in the product, they are same. So we are going to understand about the balanced and unbalanced equation. So what is a balanced equation? When the number of atoms of the elements in the reactant is same as the number of atoms of those in the product, then those equations are called as balanced equation. And if the number of atoms of the elements in the reactants are not same to the number of atoms in the products, then the equation is called as unbalanced equation. Now let us understand this balanced and unbalanced equation with the help of a video. Okay, we'll see a video related. students, as we have seen in the video how the reaction has to be balanced, the equation has to be balanced. We have also seen the example of ammonia, how hydrogen and nitrogen, they react to form ammonia, and how it should be balanced. So let us see what are the various steps to balance a equation. Okay, the first step is write the chemical equation from given word equation. First we should always write the condensed form, that is the chemical equation from the word equation. Then we have to check whether the reaction is balanced or not by comparing the number of atoms of various elements present on both the sides of equation. Okay, first, then after checking, then we will start balancing the equation, okay, which contains the maximum number of atoms. Moreover, it is convenient to consider that element in this compound which has unequal number of atoms on two sides. Then we will write the final balanced equation again. Okay, we should always keep in mind, we should always, while looking at the chemical reaction equation, we should always see that both the atoms on both the sides has to be equal, then only it is a balanced equation. Now let us see more examples of balanced equations. Okay, so we'll see one more video related to it.
We've learnt that during a chemical reaction, the original reactants are transformed into new products. A chemical equation is used to represent the relative proportions of the reactants and the products with symbols and formulas. For example, when hydrogen and oxygen combine to form water, the equation must tell us exactly how many atoms of hydrogen and how many atoms of oxygen are needed for the reaction to take place. The equation must represent known facts and accurately describe reactants and products with the correct formulas. The equation must also satisfy the law of conservation of mass. According to this law, the total mass of the elements present in the products of a chemical reaction will always be equal to the total mass of the elements present in the reactants. The law of conservation of mass is based on the fundamental principle that matter can neither be created nor be destroyed. We can see how this law holds true with the example of fossil fuels. Coal is a fossil fuel formed from the remains of early plants and forests. During their lifetime, these plants use carbon dioxide from the air and energy from the sun to make their food and release oxygen back to the atmosphere. After millions of years, when fossil fuels are burnt, oxygen is used up and carbon gases are returned to the atmosphere. The energy that was stored millions of years ago is released in the form of heat and light. Thus, even after millions of years, there has been no loss or gain of mass. Based on the law of conservation of mass, a balanced chemical equation is one in which the number of atoms in the reactants on the left is equal to the number of atoms in the products on the right. For example, when methane and oxygen react to form carbon dioxide and water, the equation must be balanced so that the number of carbon, hydrogen, and oxygen atoms is equal on both sides. We can use a simple step-by-step method to balance an equation. For example, when hydrogen and oxygen combine to form water, there are 2 atoms of hydrogen and 2 atoms of oxygen on the left. However, there is only 1 atom of oxygen on the right. To balance the number of oxygen atoms, we must add a coefficient of 2 to the water molecule on the right. We now have 4 hydrogen atoms on the right. In order to balance these, we must add a coefficient of 2 to the hydrogen molecules on the left. The equation is now balanced. Before balancing a chemical equation, it is important to ensure that we are using the correct formulas to represent each of the reactants and the products. For example, when methane burns in air, we know that the products are carbon dioxide and water. Next, we must count the atoms of each element on both sides of the equation and identify the element with the maximum number of atoms. In this case, it is hydrogen. There are 4 atoms of hydrogen in the reactants on the left. Therefore, there should be 4 atoms of hydrogen in the product on the right. Next, we must count and add the required coefficients to balance the oxygen atoms on both sides. Remember that in balancing a chemical equation, the molecular formula of the reactants and products does not change. The only change is in the coefficients. Once the equation is balanced, you may also need to indicate the physical states of the reactants and products. For example, gaseous, liquid, aqueous, and solid states of the reactants and products are represented using standard notations such as G, I, AQ, and S respectively. Heat evolved during the reaction is written as plus heat on the product side. Now think about this. How would you indicate that a reaction is reversible?
Let's see what are the types of chemical reactions. Combination reaction, decomposition reaction, displacement reaction, and double displacement reaction. Let us understand all these reactions with the help of examples. The first one is combination reaction. When 2 or more reactants they combine to form a single product, that reaction is called as a combination reaction. Okay, that means in this reaction there are 2 or more reactants, and when they combine they give a single product, one and only one product, and that is called as a combination reaction. Let's understand this with the help of a video.
Hello scientific people, how are you today? So today I'm going to show you the demonstration of a chemical reaction, that is burning of magnesium. So here I have a strip of magnesium which is cut from the magnesium ribbon. So this is the magnesium ribbon, and this is Bunsen's burner and a watch glass in which I am going to collect the magnesium oxide, which is white in color. These are the pair of tongs. So when magnesium reacts with oxygen, it requires heat energy, and after initiating this reaction, you will see that the magnesium burns in presence of oxygen to form magnesium oxide, and magnesium burns in oxygen with a brilliant white flame, that is called a dazzling white flame. Very difficult to see that. So let's try the experiment, and here I am going to hold this magnesium ribbon. Actually, we don't require a very big piece of magnesium. It's very handy. You can even break it with your own hands. So I choose to put all other things aside. As you can see that magnesium burns with a dazzling white flame. Now, as the reaction is completed, you can see that this white color thing is being produced, white color is nothing but magnesium oxide. Even, let's try to break it. This is white color powder. This white color powder is nothing but magnesium oxide. So as you saw, that magnesium burns with dazzling white flame. So hopefully guys, you have enjoyed the explanation. If you are not subscribed to my channel.
So as we have seen the example of magnesium oxide, magnesium and oxygen, when they combine, they form magnesium oxide. So here there were two reactants and they formed a single product, that is magnesium oxide. So it is an example of a combination reaction. The same experiment we will be doing in our lab when we'll meet in school. Okay. The second type of reaction is decomposition reaction. The chemical reaction in which two or more products are formed from a single reactant is called a decomposition reaction. That means it is the opposite of the combination reaction. Here we have only one reactant, and one reactant, it decomposes and give two or more products. Okay, let us see the example related to it with the help of a video.
Decomposition reactions. The reaction in which a single compound breaks up into two or more simple substances is known as decomposition reactions. The decomposition reaction generally takes place when energy in some form such as heat, electricity or light is supplied to the reactants. CaCO3 when heated gives CaO plus CO2. Decomposition of a substance by heating is thermal decomposition. Electrolysis. The decomposition of a substance by passing electric current through it is known as electrolysis. Sodium chloride 2 electric current through it is known as electrolysis. Sodium chloride 2NaCl on passing electric current gives sodium 2Na and chlorine Cl2. Photolysis. The decomposition of a compound with light is called photolysis. Study of decomposition of silver chloride. Take about 2 grams of silver chloride in a china dish. Place this china dish in the sunlight for some time. It is observed that the white silver chloride turns grey on exposure to sunlight. Silver chloride 2AgCl on exposure to sunlight gives 2Ag silver and chlorine Cl2. Silver bromide undergoes decomposition when exposed to light. Silver bromide 2AgBr when exposed to light gives 2Ag silver and bromine Br2. The above reactions are used in black and white photography.
Students, next is displacement reaction. The reaction in which the place of the ion of the less reactive element in a compound is taken by another more reactive element by formation of its own ions is called displacement reaction. In simple words, what is displacement reaction? When a less reactive element is displaced by a more reactive element. Okay, so that is a displacement reaction. Let us understand it with the help of a video.
Displacement reaction. The chemical reaction in which one element displaces another element from a compound and takes its place is known as displacement reaction. For example, when zinc Zn is added to copper sulfate CuSO4, it displaces copper from copper sulfate, giving ZnSO4 zinc sulfate plus Cu copper. Study of a displacement reaction. Take a test tube and add about 10 milliliters of dilute copper sulfate solution to it. Take an iron nail. Tie the iron nail with a thread and suspend carefully in the copper sulfate solution. It is observed that the blue color of the solution starts fading and the iron nail becomes brownish in color. The change takes place due to the following displacement reaction. Fe, iron, reacts with copper sulfate, CuSO4, giving ferrous sulfate, FeSO4, and copper, Cu.
Yes students, this was displacement reaction. The last one is double displacement reaction. The reaction in which the ions in the reactants are exchanged to form a precipitate are called double displacement reaction. Here the ions of both the reactants, they get exchanged and a precipitate is formed. Okay, so this is a double displacement reaction. Let us see a video related to it.
Double displacement reaction will require sodium sulfate, barium chloride, dilute HCl, a beaker, conical flask, and test tubes. Take a small quantity of barium chloride in a test tube and transfer it into a conical flask. In another test tube, take a small quantity of sodium sulfate and transfer it into the conical flask containing barium chloride solution. A white precipitate of barium sulfate is formed immediately. This confirms the presence of sulfate, SO4, 2- ions. Stir the contents of the conical flask and keep it undisturbed for some time. The precipitate of barium sulfate settles down. Decant the upper solution from the conical flask into a beaker. Then add a small quantity of dilute HCl into the conical flask containing the precipitate. Swirl the flask well. The white precipitate is insoluble in dilute HCl. In this chemical reaction, sulfate ions are displaced by chloride ions and chloride ions are displaced by sulfate ions. So the reaction is a double displacement reaction.
So students, that was all the 4 types of reaction. Now including these 4 types of reaction, there is always a exchange of heat takes place. Like in some of the reactions heat is liberated, in some of the reaction heat is absorbed. Okay, so based on that, there are 2 types of reaction, that is endothermic and exothermic reaction. Let's see what is endothermic reaction. The reaction in which heat is absorbed is called as an endothermic reaction. The example is potassium nitrate. When potassium nitrate is dissolved in water and heat is applied to it, then the aqueous potassium nitrate is formed. When the solid potassium nitrate is added to water and it is heated, we get aqueous potassium nitrate. Okay, so here the heat is absorbed, so it's an endothermic reaction. On the other hand, what is exothermic reaction? The process in which heat is given out, heat is liberated, is an exothermic reaction. We have taken example of sodium hydroxide here. When sodium hydroxide is dissolved in water, okay, and if you touch the test tube, so you will observe the heatness, the heat is getting evolved, the test tube will become a little warm. Okay, so this shows the evolution of heat, okay, which gives the rise in temperature. So it's an exothermic reaction. So students, this was our topics that we have discussed today. We have discussed how to balance an equation, what are the steps to balance the equation. Then we studied the 4 types of chemical reactions. Okay, and the last one we studied about exothermic endothermic reaction. Okay, and the assignments that related to this topic will be sent to you after this. Okay, so you are expected to complete this that assignment and submit. Okay, Sai Ram students.